Now, in this video, we are going to take up one more problem, how to solve this problem by using the sketchbook, and also how to analyze this problem. The problem number 104. A pentagonal lamina having edges 25 mm is placed on one of its corners on HP, such that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30 degrees to HP and 45 degrees to VP. Draw the top and front views. So as it says, it is resting on one of its corners on HP, and since it is a pentagon and it is a odd size, so either it is resting on one of its corners or on the side. In any case, the initial position will be a side which is perpendicular to VP has to be considered. So this is how we are going to be placed on the initial position. And as we see, is placed on one of its corners. So this side is a corner and opposite to this will going to be a side. So this is how the initial position, and the surface is parallel to HP. So we are getting the true shape in HP of 25 mm side, and the surface is perpendicular to VP. So we are getting a line in the front view. As we look from the front view, ABC is near to the observer. So A dash, B dash, C dash is visible. D and E is away from the observer. So D dash, E dash becomes invisible. So this MP has shown only because it is the perpendicular bisector of the edge passing through the corner. So which is the edge perpendicular bisector of the edge passing through the corner? The corner is A. Passing through this corner is the perpendicular bisector. Opposite to this is the CD. And when you join, when you draw a horizontal line, so this will going to become the perpendicular bisector. So to this line, this bisector will be at 90 degrees. So that is the reason why it says it is the perpendicular bisector. So when you see the orthographic view, here ABC is the pentagon of 25 mm side, so that the surface is parallel to HP. So you are getting the true shape in HP. And since the surface is perpendicular to VP, so you are getting a line. And AM is the perpendicular bisector. You can see that it is A dash, M dash. Then when you go to the next position, so that it is resting on one of its corners on HP. So it is the resting corner on HP. So that the perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 30 degrees to HP. So since it is a true inclination, so as we see when you look from the top view, so these two perpendicular bisector, that is AM, is parallel to VP. So you are getting the true line, and the inclination given is the true inclination. Therefore, as we rotate the surface, since the perpendicular bisector is also on that surface, the perpendicular bisector will also be inclined at 30 degrees to HP. So this is how you will be able to get the second position. So once the second position, you can see here the corner is resting on HP, and the perpendicular bisector is of the lamina is passing through the corner on which it rests is inclined at 30 degrees. So once the surface is inclined, the perpendicular bisector is also inclined. So this you write the second position top view. As the perpendicular bisector becomes inclined to HP, so what happens to the apparent length of the perpendicular bisector? The apparent length of the length of the perpendicular bisector in the top view will going to become inclined to HP. So obviously it will going to become the apparent length. Now as this perpendicular bisector of the passing through on which the lamina rests is inclined at 45 degrees to VP, so we need to consider this. So here he has given the true inclination, but what we have is the apparent length here. So since with the perpendicular bisector, the apparent length what you have in the second position top view, and the inclination given is the true inclination, so we cannot rewrite the second position top view in the third position directly, because this length is the apparent length, the inclination given is the true inclination. So first we need to consider the true inclination. So how to do that? Take any convenient distance from the second position top view and also from the XY line, and you mark this point as A and draw a horizontal line. Then as it says it is 45 degrees to VP, so you measure through the point A, you measure a horizontal angle of 45 degree and draw an inclined line. So once you draw this inclined line, as we know that it is the true inclination line, and then you take the true length of the perpendicular bisector. So which is the true length of the perpendicular bisector? You from the compass you measure the distance between AM So you measure the length by using the compass. You measure the perpendicular bisector of the first position from A and M with A as center. Cut an arc on that 45-degree inclined line. Then from through this point you draw a horizontal line. Then again you measure the distance from the second position top view, which is AM, by using the compass with A as center. Transfer it on to the locus line. Then you mark this point as small m, and then you join these two lines. Then join these 2 points. Then this will going to be the apparent inclination. Once you get the apparent inclination, then on that inclination you rewrite the second position top view, and then you get the corresponding front view in the third position. So that is what we have done here. So as we have rotated at 45-degree, and then since it is the apparent inclination, we want apparent length. We got the apparent length, so you rotate that such that this will going to become on this apparent inclination line, so that this will going to be coincides with this particular apparent length. And once you get this, so to this you will going to get the corresponding front view. So this is how the analyzation will going to take place. Now we are going to try to solve this problem using the sketchbook. So first we are going to draw the XY line, and you mark this as VP and HP. Then you measure 25 mm line and draw a vertical line in the top view and at any convenient distance from the XY line. Then you mark this point as C and D. Then through C you measure an angle of 108 degree with respect to CD, and then draw an inclined line. And again, by using the protractor with D as center with respect to CD, you measure an angle of 108 degree and then draw an inclined line. Then by using the compass, you measure the distance of 25 mm with C as center, cut an arc on this 108 degree line, and also with D as center, cut an arc of 25 mm on this 108 degree line. And you mark this point as small e and small b. Again with B as center, taking a radius of 25, draw an arc with E as center, cut on the previously drawn arc, and you mark this point as small a. Then join A to B, B to C, C to D, D to E, E to A with a dark line. And then you join from A, you draw a midpoint of CD and you mark this point as EM. Then draw a vertical thin projector line from A to the XY line, and also from C, M and D to the XY line, and also from B and E to the XY line. And you mark this point as A dash, and then B dash and E dash in bracket, C dash, D dash and M dash in bracket. Then join A to A dash to B dash and B dash to C dash with a dark line, so that you will going to get the front view. Then can take any convenient distance from the first position front view, and you mark this point as small a dash. Then from here, by using the protractor, you measure an angle of 30 degree with respect to the XY line, and you draw an inclined line. Then with A dash as center, by using the compass, you measure the distance from A dash to C dash D dash. With A dash, cut an arc on that C dash D dash line, and you mark this point as C dash and D dash in bracket and M dash in bracket. Then you measure the distance from A dash to B dash, and you transfer from A dash on this 30 degree line, and you mark this point as B dash and E dash in bracket. Then you draw this inclined line of 30 degrees with a dark line. Then you draw a vertical projector from A dash, and you draw a horizontal projector from A. Both these two lines will be going to intersect at this point, which is A. Then draw a vertical thin projector line from B dash and A dash, and draw a horizontal projector from B and E of the first position top view, and these two lines will going to intersect at this point, and you mark this point as B and you mark this point as E. Similarly, draw a vertical projector from C dash, D dash and M dash, and draw a horizontal projector from C and also from M and also from D. All these three lines will going to intersect at C, M and D, and you mark this point as C, M and D. Then join A to B, B to C, C to D, D to E, and E to A with a dot line. So this is how you will be able to get the second position top view. Now we need to write the third position top view. So to do that, as we know that as the surface is as the perpendicular bisector of the edge passing through the corner is inclined at 30 degrees, obviously you're going to get the apparent length in the second position top view. But actually in the problem he has given the true inclination. So take any convenient position from the second position top view, and you mark this point, and you mark this point as A, and draw a horizontal projector here. Then with A as center, taking the by using the protractor, you measure an angle of 45 degree with respect to the horizontal, and you draw a 45 degree line, and this is gauged as shown here. Then since it is the true inclination line, you have to take the true length of the perpendicular bisector. The true length of the perpendicular bisector will be here or also here. Both will going to have the same distance. So by using the compass, you measure the distance from A to M of the first position top view with A as center cut on the 45 degree line. So you will going to get this line here. Once you get this line here, you draw a horizontal projector here, which is the locus line. Then you take the compass, you measure the distance from A to M of the second position top view with A as center and cut an arc on that locus line, and you mark this point as small m. Then join A and M with a thin line. Then you measure the distance from A to this point and transfer from A on this beta inclination line, and you mark this point. Through this point, you draw a perpendicular to this inclined line AM, which is the beta inclination line. You mark this as beta. Then you measure the distance from this point to B and also from this point E. Both will going to have the same distances in the second position top view, and transfer from this point towards the right side to get this point B, and from this point towards the left side to get this point E. Then you mark this point as C, and then through this point you draw an inclined line with respect to AM. Sorry, draw a perpendicular line with respect to this inclined line AM, and then with taking the position of the M point in the second position top view, measure the distance from M to C and M to D. Both will going to have the same distances by using the compass. With M as center in the third position top view, cut an arc on below that line, below that M, to get this point C, and also from here towards the left side to get this point D. Then join A to B, B to C, C to D, D to E, and E to A with a dot line. And then draw a horizontal projector from A dash of the second position front view, and draw a vertical thin projector line from A to the XY line, and you mark this point as A dash. And then draw a horizontal projector from B dash and A dash, and draw a vertical projector from B and E from the third position top view. Both these two lines will going to intersect at this point and also at this point, and you mark this point as B dash and E dash, and draw a horizontal projector from C dash and D dash, and draw a vertical projector from C and D. Both these 2 points will going to intersect at this point, which is C dash, and also at this point, which is D dash. Then join A dash to B dash, B dash to C dash, D dash to D dash, D dash to E dash, and E dash to A dash with a dot line, and you mark this point as Y, and mark the dimension of 45 degree, and here beta, and this is 30, and this is 25. And these dimensions, whatever we have shown here, it is only for the reference. So this is how you will be able to analyze and solve this problem by using the sketchbook. Thank you.